For lesson 78, we're working with products of square roots. We talked about this lesson the other day when we were simplifying square roots and how we went about simplifying them. So a little review. If we go back to that lesson, one of the examples that we looked at was the square root of 8. Now, we all know that the square root of 8 is not perfect. You know, square root of 9 is, but it's not the exact same. So we talked about how we went about simplifying the square root of 8 and how we could break it down. So what we did for like a number like 8, that's a smaller number, we identified two factors of 8. And the two factors that we would like to use are going to be 4 and 2, because we all know 4 times 2 will get us 8. And then after that, what we did is we split these up. And the reason we split them up, because now we know that 4 is a perfect square root, which means the square root of 8 can simplify down to 2 square roots of 2. Today we're doing the exact same concept, but now we're going to do it with multiple square roots. So another example today could be like the square root of 2 times the square root of 3. Now here we see that there's 2 square roots, and notice neither one of them are perfect, and you know that's okay. But what we can do is we can go ahead and multiply these two together to get the square root of 6. Now if we wanted to, we would try to break down the square root of 6, but it can't be broken down any further because the only factors of 6 are going to be 2 and 3, and neither of those were perfect. So sometimes they will just ask you to multiply 2 square roots together, and all you got to do is multiply the 2 and the 3 and you have the square root of 6. If we take a look at example 1, it's really kind of the same setup. We have the square root of 3 times the square root of 12. And what we want to do is we want to go ahead and combine the two of them together again and get it down to a single radical, because if we do that, then I think we'll be able to break it down from there. 3 times 12 will get us 36. And if we take a second to look at that number, we notice that 36 is a perfect square root. So it actually reduces all the way down to 6. If we look at example 2, a little bit bigger problem, we have the square root of 42 times the square root of 24. Okay, so what we want to do for these is notice 42 and 24 are bigger numbers. We could multiply the 42 and the 24 together right away, but I think the best option is going to be to go ahead and do our prime factorization method. So let's go ahead and take a look at 42. Prime factorization of 42, we could go 2 and 21, keep it easy for ourselves. And then if we look at 21, it could be 3 and 7. Both of those happen to be primes, so we know that 42 is 2 times 3 times 7. If we look at 24, we know factors of 24 can be 4 and 6, which go down to 2 and 2, and 3 and 2. So what we want to do now is we want to take these prime factors. So we had the square root of 42 times the square root of 24. We want to take this list of primes and we want to combine them all into one radical. You know, if we go back to 42, we had 2, 3, and 7. And maybe instead of combining them all into one radical right away, maybe let's look at it this way. Now let's look at the square root of 24. Well, we got that list of primes to be 2, 2, 3, and 2. Now, why is that beneficial? Well, again, the objective behind the prime factorization method is to be able to pair these primes together. So what we want to do next is we're going to create the whole square root now. And now I want to take all of the 2's that I have and put them first. So 2, 2, 2, and 2. I have 4 2's available. And now let's go to the next number, which is 3. Well, if we look at the 3's, we have 1 there and we have 1 there. So we have 2 3's, and then we have the 7 left over. So we're going to put that on there. And the reason we want to put these numbers that are alike together is because now at this point, we want to start pairing those numbers together. I notice that I have a pair of 2's at the beginning. I have a pair of 2's there. and I also have a pair of 3's down here on the right. So what we want to do at this point, it's just the same procedure that we did in the last lesson, is we want to take those pairs and put them in their own radical. So 3 and 3 will go in their own, and then whatever's left over will go in its radical by itself at the very end. And again, the pairing method, what it does for us is it guarantees us to get all of the perfect square roots that are available to us. 2 times 2 is 4, 2 times 2 is 4, 3 times 3 is 9, and the square root of 7 is just the square root of 7. And at this point, square root of 4 is 2, square root of 4 is 2, square root of 9 is 3, and then we have that square root of 7. And we are almost done. Now what we want to do is take our 2 times 2, which is 4, multiply it by the 3, and get 12. So this example that we did for example number 2 is a little bit more advanced. Okay, but it's still the same process. You know, prime factorization, list the primes, pair the primes, and then put them primes in their own radical so that we can simplify those perfect square roots. I want to do one more with you. Let's take a look at example number 3. Here we have the number 3 out in front with 2 radicals, the square root of 6 and the square root of 15. Now the 3 we're just going to hang on to for right now. We're going to come back to that in a little bit. But what we want to do here to begin with is just start doing the prime factorization again. If we look at 6, the prime factorization of 6 is simply 2 and 3. Easy enough. If we look at the 15, you know, and do its prime factorization, we know 3 times 5 will get us 15, and both of those are prime. So the 3 again is just given to us out in front. The square root of 6 is given, and the square root of 15 is given. Now, if we look at the square root of 6, we list those prime factors, that's 2 and 3. And if we look at 15, those prime factors are 3 and 5. And again, what we want to do with those square roots is we want to combine them all into one. 2, 3, 3, and 5. Because what that'll allow us to do is to be able to identify where is our pairs located at. So we have 3 times those pairs, 3 and 3 will get put together. The leftovers, 2 and 5, will just get put on the end. And now what we want to do is take 3 times the square root of 9 now. And let's go ahead and multiply the 2 and the 5 to get 10. 3 times 3 times 10. Lastly, we know 3 times 3 will get us 9 times the square root of 10. And we can't simplify that any further. So there are some problems for you to work on. Okay, good examples to keep in your notes. The practice set problems that I want you to work on are going to be A, C, and D.